is exponentials. Do you get by now that some of these are growth and some of these are decay? I would say most of them are growth. Can you point out any one of them that is decay? Were you looking at this one? That's the only one that's going down as you read from left to right. So that would be the only one that would have a fraction in it to a power. Remember that. If this is less than 1, you've got decay. There's always an x in the exponent. Now, where some of these moved around, yeah, look at this one. This one goes through 3. This one goes through 4. This one goes through 1, which is the normal thing it goes through. So some of them have been moved up. So let's go off to the side here, and everybody write this down. Y equals 3 times 2 to the x minus 1. And I want you to label a few things with me. Oh, wait, and then put a plus 5 out here. Here is a typical test question. What was the growth or decay factor? Well, do you know which of these numbers tells me the growth or the decay? Is it the 3? Nope. Is it the 2? Yup. That one right there tells me it's growth. Why is it growth? Yes?
Because it is greater than 1.
Because it's greater than 1. If it had been a fraction, then it had been decay. So this one tells me that growth and decay. So take some notes on this. That's where the growth was. Next, what's that thing? The y thing. Y equals 5. But what's that again called? That's called the something something. It's horizontal. I said horizontal so that you would remember that y goes with horizontal. Asymptote. So the asymptote, you know that dotted line thing? It goes through at 5. Okay, next thing. Is this up or down? Up. This one right here, that might seem like it's down 1 because, you know, if it was on the outside, it would mean down 1. But what does that minus 1 actually mean? Right 1. Very good. And one thing I have never told you, but I'm about to. This front number, I never gave it a name before. But now you're getting further into the unit, so you can handle this. That is called the start value. What that means is if you get rid of everything else and you like make this part equal to 0 and you didn't move it up, then you would have started with a 3. So it's like you start with 3 cats and then you follow this function and it'll make the tell you how many cats you'll have over time. Well, if they're all male cats, then you're just going to have 3 cats. But if you have a male cat and a couple female cats, you're going to have lots of baby cats. Okay, so then it would make it grow. So this would be how many cats you had to start with. This would be the growth rate. This would be if you shifted this thing to the right or left, and this would be the shifting up and down. Okay. Next, I got to get into, what if I said y equals 4, that's the starting value, times 1.3 to the x. Now we got to get a little more specific. 30% growth. You should have known it was growth because it was bigger than 1. But how much bigger than 1 is it? Because that will tell you what percent growth you have. Do you get timesing by 1 doesn't really change anything. So timesing by 1 point something, the part that's above 1, that is your growth. So that would have 30% growth. All right, how about this one? Y equals 4. 4 is the starting amount again. Let's say you have 4 cats, 2 boy cats, 2 girl cats, and you have this. Well, that means you're a terrible cat farmer because your number of cats is shrinking over time. Do you get that that's decay? Well, maybe your cats are too old to have babies, and maybe they're just slowly dying off. I don't know what would happen if you have really old cats. You know, if you have 4 older cats, eventually one's gonna die and you'll have 3. And okay, so this is decay. That means the number of cats we have is shrinking, but it is not 85% decay. Think about it. It's some other percent decay. Can you do it? It's usually a few kids that are like, oh yeah, that would mean this percent decay. Yes. 0.15 decay. Now, do you agree that most people would say that 15%? But do you get how the 0.85 and the 0.15 add up to 1.0? It's like, how much less than 1 is it? So I like to write these like this. And we'll see. Some of you will use my method and you will do quite well with it. I always write these as 1 minus something. And then I go, oh, so how much would I have to subtract from 1 to get 0.85? 0.15. So then that is how much different than 1 it is. You know, the other one was like 1.3, so the amount it was different than 1 was the part after the 1. We'll see if you write it like this, 1 minus 0.15, then this part right here shows you everything. It shows you that it's decaying, because you're subtracting from the 1, and how much it's decaying by. So this 0.85 right here, that I'm highlighting in pink, is the exact same thing as 1 minus 0.15. So if you always change yours to a 1 plus something or a 1 minus something, I promise I'll never give you one that's just 1. Because, you know, multiplying by 1, it doesn't do anything. It's very boring. You're never going to have a 1 as your base. Because if we times by 1 over and over again, nothing changes. So we're always going to say something bigger than 1 or something less than 1. All right, so I started with this problem. 4 was the starting amount. This was decay, so I wrote it like this. And I know it's 15% decay. That means slowly I'm losing 15% of my value over time. Every time I go another year, I lose another 15% on average. Okay. Let's see if you really got that. What if I add 1.87 to the x, and there's only a 1 in front? Then what was my start amount? Don't overthink this. 1. I started with 1. How much is it growing? If you say 1.87, I'm going to have to mark it wrong. How much is it growing? Hint, it's a percent.
Is it 87%?
It is 87% growth. Because it's how much bigger than 1 it was. So then what if it goes the other way? Y equals, let's say I start with 2 of something and I go 0.91. Well, that one is not growing. It starts with 2, and I think some of you can write it this way. And as soon as you do, you'll be able to be like, oh, I can see what percent decay that is. How many of you figured out it'd be 1, but take away 0.09? 9% decay. I'm curious, how many of you actually got 9% before I said it? Good. Okay. Do you get this one's decay because it's going less than 1, and that's how much it went down, 9%. All right, so your problems used to look like this. Y equals 2 to the x. Now they're going to look more complicated. They're going to be decimals there. You can totally use the calculator, but it'll be like y equals 4 times 1.6 to the x. You still do the exact same thing with your xy chart. You put in 0, -1, 1, 2, but you'd use a calculator, and you'd have to be able to say, is this growth or decay? Say it. Growth. What percent? Be careful. Not 0.6%. 60%. Good. Why not 6%? It would have had to be 1.06 if it was going to be 6%. This is 0.6. I could put a 0 after that, right? So then that's 60% growth. What was my starting value? 4. So I started with 4 cats. I'm getting 60% growth in my cat population. My daughter, I use cats a lot because my daughter actually raises cats. She's a kid just like you a few years ago. Went off to college, got her degree, ended up realizing, man, I can make more money selling cats than in my engineering job. So she decided to just raise cats. It actually does that. So this has 60% growth. That's the starting amount. What's that? That's where time goes. So if my daughter wanted to know, let's say she looks up and says, a good cattery will get 60% growth. As long as you feed the cats well and you know, breed them properly, you'll get 60% growth. Then this would be the number of years. So let's say this is over 4 years. So then you'd see how many cats does she have after 4 years. Well, you stick a 4 in there, you use the calculator, you put that to the 4th, and then you times it by 4, and then you'd see how many cats, and it'd be a lot. But it kind of makes sense because each cat can have like 6 babies when they have a set of babies. And then they can have babies twice a year. So one cat can have 6 babies and then 6 more babies, and all of a sudden you've got 1 plus the 6 plus the 6 makes 13 cats from just one that you had. So the growth rate's actually more than this. Okay. Now you're not going to ever do it perfect because you're never going to breed them at exactly the right time, and you might have 6 babies, but sadly it happens. You're going to lose one every now and then because it just doesn't thrive. And so the growth rate won't, you know, work out just like you think it's going to. But if I put in -1, I would put it here, and I'd see what point I got. I put the 1 right there. And I guess all I'd have to do in that one is 4 times 1.6, because to the 1 doesn't do anything. So what is 4 times 1.6? 6.4. And I could graph it. And I put in 0. If I put in a 0 right here, anything to the 0 is just 1, and that's my starting amount. It's like at times 0, I have 4 cats. Now I know in the real world you can't have 6.4 cats, but it's kind of like, do you get in the real world, you can't have 1.2 kids, but that's like the average number of kids people have. You can't have 0.2 of a kid, but yet the average is 1.2. If I put in a 1, then the 1 would go right here, and I go 1.6 to the 1 times 4. What is 4 times 1.6? And it's 6.4 again. What just happened? There, that's 6.4. Oh, I made a mistake back here because I didn't put it to the -1. I apologize. I was putting in a regular 1 on this spot. I should have put in a -1. So then, what is 1.6 to the power of -1? That's 0.625. What is 0.625 times 4? 2.5. Sorry, I screwed up my first one because I didn't put in a negative. My bad. Then, if I graph all of these points, big surprise, it looks kind of like this. And where's the asymptote? Well, there isn't any number out here. There's like a 0 out there, so then the asymptote would be right here at y equals 0. All right, basically it's just the same thing we've been doing, except now you got to be smarter about what the parts mean. All right, everybody get to this one. You may ask a question.
Why was the 2 6.4?
Because of the fact that I can't go back on this slide without messing up the recording, I can't do that. But if you ask me later, I will happily work it out with you later. Okay, so just got to wait till later. If I go backwards, my recording will be all messed up. So, everybody start with this one. 1.3 to the x. I'd like you to find 3 points. Put in -1, 0, and 1. I'll be calling on different people to give me what is -1. When you stick in -1, what do you get? When you stick in 0, what do you get? And then we'll graph it. Dasha, when you put in -1, you're putting it right here. What does -1 mean when you put it as a power?
It means like it flips.
So the answer is?
3.
Correct. So that's a 3. So -1 comma 3. Would you expect this to be growth or decay? Do you agree that that's less than 1 and therefore this is decay? All right, so my graph should slowly drop. All right. Aurelia, when you put in 0, what do you get?
1.
Correct. 0 comma 1. It's right there. Is it slowly decaying? Yes, it is. It's going down. And then I put in a 1. Aben, when you put in a 1, what do you get?
I got like 0.33.
You are correct. That's the same as 1/3, because when you put in a 1, 1/3 to the 1 is 1/3. So 1 comma 1/3. If I graph that, it's kind of like that-ish. And look at that. It's going down just like we'd expect. And isn't there an asymptote line that runs along here? Oh, yes, there is. Because it's always whatever's on the outside of this, which is 0. And so it's y equals 0 is the horizontal asymptote. All right. Describe the transformations. Ooh, all I got to do is say where it moves. 2 to the... Come on, say it. Don't be afraid or shy. 2 to the right. And how about this 3? Up 3 is correct. Okay. And then, what is a reflection? That's where you put in a negative. Did this graph have a negative in it? No, it had a -2. That's not the same as a negative. So let me show you what happens if I do a reflection. That's like if I had y equals 2 to the x, and then I throw in a negative like here. Do you get if I put a negative in the front, the graph's got to change. So let's talk about what it would do. This is a normal graph. When you have a vertical reflection, that's an up-down reflection. Some of you are good at this in your head and some of you aren't. Can you see that it would go like that? Those of you that are good at this, do you get it just vertically flips like that? So some of you are good at spatial stuff and you'll be like that. That's no big deal. If you put in a negative, that's a reflection. Then the graph just flips over. You can also do horizontal ones. If I flip this horizontally, it's going to make your brain hurt a little bit. But if I go this way, it would look like that. I'll do it in green. Okay, so the black one is a vertical flip. The green one's a horizontal flip. All right. What do you think that negative does? Please don't say flip. What's the official word? Reflect. Remember how on last assignment it didn't matter which way we reflected? This time it does. Is this considered on the inside or on the outside? Inside. So then this is horizontal on inside. High vote. Man, there's so many things to remember in math. And they keep coming up. It's the same thing we did before. Horizontal on inside, vertical on outside. So this one's horizontal because it's on the inside, so that's a horizontal reflect. I am totally fine with you not spelling out horizontal. Just put H reflect, and I will get you mean horizontal reflection. That is not a horizontal reflection. It's a V reflect. And nothing else has happened to it, so there's no move to the right or down or... Okay, how about this one? Well, first thing I notice is it's decay, but they didn't really ask me, but it is. And then they have a negative here. That's a reflect, but what kind of reflect? Horizontal reflect, because it's on the inside of the function. Inside by the x. Whenever you're like deciding where's the inside of the function, it's by the x. So is this inside by the x? No, this one's not inside by the x, so that must be outside, so that must be a high vertical on the outside. Oh, it's a vertical reflect. And that is decay. Okay, we're getting there. If you had to graph this, do you get a normal growth is like that, but this is going to reflect that. It's going to flip it. It's going to flip it horizontal on the inside, so it should look something like that. I'm just ahead of time saying I think it's going to look something like that. I'm not saying that's my answer, but my answer will kind of look like that. Then I actually find 3 points. Take a wild guess what I'm going to put in. 1, 0, and -1. Good. Now, people get confused by the negative. They're like, that negative there, should that, if there's another negative, should I count both of them? I get the confusion. I do. Don't overcomplicate this. If x is 1, you just put a 1 right where the x was. Not where the negative was, just where the x was. So that reads 3 to the -1. What is 3 to the -1? Come on, 3 to the -1. 1/3 is correct. Then I put in a 0. -0 is kind of a trick question because -0 is just 0. What's 3 to the 0? 1. And last but not least, this is the one that gets people confused. If I put in a negative where there's already a negative, do I just like, well, there's already a negative there, so I don't put in, no. You're just replacing the x with exactly what it said, which is -1. So I'm putting in a -1 there, and there's 2 negatives now. So that makes 3 to the +1, which is just 3. And if you graph these, you will see that it kind of follows where I said it would. It's not perfect, that's why we make the points. But see how the blue one is kind of like what I suggested it would be with the red line? It's decay, it's going down. And the asymptote to be right there at 0. Okay. Pop your name tag right here, it'd be fine. All right, so I don't want to do all of these examples because from here it's going to get really boring. They're just going to make you put in 3 points over and over again. Put in 0, put in 1, put in -1. Graph it, and you go, oh, this was going to be decay, so it was going to look like this. But then they put the negative on it. It's a vertical flip, so then it's going to look like this. But exactly where is it? You don't know it till you make the points. But I know it kind of looks like that blue line with the points. So everybody get to this one. On mine, it's page 8. I think it'll be page 8 for you too. Everybody get to page 8. Okay, so this is a pretty tough one. Cooper, is this growth or decay?
Decay.
Because what?
There's a fraction.
Yes. Right here. That tells me it's decay. Will my whole graph be reflected? Yup. Because of this. But is it a vertical or horizontal? Well, to answer that, you got to ask, is it on the inside or the outside? It's on the outside. VO. Try to remember VO. Vertical on outside. So that's a vertical reflect. What's this +4 doing? Up 4. And it's also the y equals 4 asymptote. Don't forget that the y equals 4, the horizontal asymptote, goes right through that. And then if I'm going to pick some points, you're going to put in 0, 1, -1. And what if they go off your graph? Well, then pick other points. It's not like you're only allowed to put in 0, 1, and -1. You can put anything you want. So maybe I'd like to put in 2 because I know it's going to work nice. You know, 2 minus 2 is 0 power. Anything to the 0 power is 1. 1 plus 4 makes 5. That was really easy. I like 2 better, so use 2. You can use any numbers you want. I just suggest you always start with 0, 1, -1, and then if you want, you can pick other numbers. And once I graph those, it's easy. All right, this is the part where I'd like to open up the worksheet. Everybody find the worksheet that's posted for today. Open up the worksheet right now, please. This isn't identical to yesterday's worksheet, is it?
No.
Okay, good. All right. We're going to do the A and the C parts. 1A, 1C, so you can skip the B parts. Cross off both B's, okay? So 1A, and then we'll skip B. 1C, and then we'll skip the next B. So again, the only ones you're skipping are the B parts. All right, Graham K, can you read me 1A?
Yeah, what's that? It's like parent function,
Okay.
and then it was fx equals 2 to 5x.
2 to the x. Is that it?
Yeah. Well, then that says transform function, and it's like 2.
Oh, read me the other one.
Yeah, and then 2 to the positive negative x.
Ah. So they want you to do, and I've been doing y equals, do you get f of x is the same exact thing as y? I like to write y instead of f of x because my graph has x and y on it, so I just like to use y wherever I see f of x. If I'm going to graph this thing, do you get I need some points? So Graham, what are the 3 biggies that I've suggested you always put in?
-1, 0.
Yep. Now we'll stick in -1. Negative goes right where the x was. Notice there's 2 negatives then. So that's 2 to the 1, so that's just 2. And then you stick in 0. -0 is really just 0. So 2 to the 0 is 1. And then I put in a 1. 2 to the -1, hopefully by now you've learned that that's 1/2. If you graph these points, you will see that it was going to be growth, but it got flipped. Like it would have looked like this, but it had a horizontal reflect, so it kind of looks like this black one now. And if I actually graph, I can see where the points are. So here's the exact points. -1, 2, it's like maybe there. 0, 1, that's like maybe there. And 1, 1/2, that's like maybe there. And my line wasn't perfect. I didn't expect it to be. But now, I can draw in my line. Asymptote, right through there. What's ever on the outside? Y equals nothing on the outside. So it's y equals 0 is the horizontal asymptote. There we go. So, do problems A and C for problem 1 and 2. And that's all I got for you for today.